Good afternoon, everyone. Let's start. So please click on yes for present. Guys, doesn't mean it's the only one. I will consider many. I will take many attendance. It doesn't mean now you are done because you are present. I will take 3 attendance today. Fatma Shmeli. Okay. So let's continue chapter 7.2. So we talked about, we have seen multiplicity, guys. We have seen if we have characteristic polynomial p lambda, which is determinant lambda in minus a. Do you remember this one? So if we find if we compute the determinant, this determinant, so we get the characteristic polynomial, and if we get like this, lambda minus a1 here number to the power of m1 multiply lambda minus a2 to the power of m2 multiply etc. lambda minus an to the power of mn. In this case, m1 we call it multiplicity of a1. This a1 is eigenvalue, a2 is eigenvalue whose multiplicity is m2, and an is eigenvalue multiplicity is an. So we have seen something similar. Now let's do an example. If a, so please guys take screenshot for this one about multiplicity. Okay, guys. Number here, number. Numbers. Okay, Muhammad. Here we have lambda minus, let's say, for example, p lambda equal lambda cube, lambda minus 1 square, lambda plus 2. So how many eigenvalues do we have? How many do we have? So if p lambda equals 0, so we have, no, false. The first one here, lambda minus 0 to the power of 3. So eigenvalue 0 with multiplicity. What? 3. Eigenvalue 1 with multiplicity. How much? What's the multiplicity of 1? 2. Very good. And eigenvalue minus 2 with multiplicity what? Very good. 1. So please take screenshot. So 2 simply here. What's the power? Power of this factor. The 1 is 2. 2 minus 2 is 1. Here 0 is 3. So we have 3 eigenvalues. Here multiplicity 3, 2, and 1. If you add the multiplicity 3 plus 2 plus 1, we get how much? 6. So here the matrix is 6 by 6. Very good. So please take screenshot. We are still doing chapter 7.2. On Thursday, guys, we do revision. You come with your questions. Okay, Abdullah. And guys, for a final assessment, it will be online, okay? So you have, it's similar to ICA. It means you have question 1, integrity statement. And in the integrity statement, don't forget you have to put civil ID or a UN card. You need to put original. Civil ID or a UN card. Original, don't forget. We have to see it. If you have here paper, we have to see that this one is original. It's not something you have a paper or scan from before. Original. You must see the original. Plus signature, and then true false, multiple choice, and question 2, which is work problem 2. Work problem 2, it has ABC. Okay, guys? After break, yes. Everything after winter break. And everything related to these chapters. Everything after winter break. Clear? From 3.4 and everything related. If we talk about subspace, you have to know what means subspace. Because we have seen dimension of subspace. So you know how to do it ICA, as we did ICA online. So you know how to answer, how to do everything. And don't forget, you transform everything to PDF, you submit. Or you can put photo. You remember input photo? Yes, it's long, but don't worry. You have time, it's 2 hours. Okay? It's not 60 minutes like ICA. You have 2 hours. But pay attention, guys. Final, you have 2 hours to submit. You have to submit within 2 hours. If you don't submit, you cannot. You don't say I have internet connection problem. I don't know any problem. You have to fix it yourself. Like in final exam, if you do an accident, it's your problem, not our problem. Okay, guys. So please fix your internet. Have another one. Make sure everything is fine and do the exam. And don't worry, you can finish before 2 hours for sure. Yes, you have 2 hours. Means you can solve it in 75 minutes and you have 45 minutes to submit. Means you have time, don't worry. You can use 2 hours, but you have to submit within 2 hours, okay? You can solve it in 75 minutes. This is what we mean by 75. Means you can solve it in 75 minutes. You get my point, Abdullah? Yes, for sure, you can use 2 hours, but don't use full 2 hours without submit. Then it's your problem. But yes, the final assessment is 2 hours. Solving plus submission. Guys, let's repeat the polling. Click on yes for present. And please take screenshot for the multiplicity. We talked before about multiplicity, and here I make it clear. So here, guys, what does mean multiplicity? If we have multiplicity equal 3, means for the eigenvalue 0, we can have maximum 3 eigenvectors. Maximum 3. For lambda equal 1, we can have maximum 2. And for lambda equal minus 2, we have 1. Because always minimum is 1. Always we have eigenvector. So here we have 1. Here we have maximum 2, 1 or 2. And here we have maximum 3, means 1 or 2 or 3. Okay, guys? For eigenvector for lambda equals 0. Maximum would be 6. Very good, Nora. Maximum. Okay? Very good. So, if A equals to 2, 0, 0, 0, 2, 1, not 0 here, 5, negative 7, negative 3, 0. A, find all eigenvalues and their multiplicity. Okay, guys, please find all eigenvalues. Take white paper and solve it, guys. Okay, guys, I'm waiting for you to solve it. Very good, Nora. No. False. Nora, recheck your calculation. Yes, very good. So let's do it in black. P lambda. And what's the multiplicity of 2? Since it's repeated 2 times means, so here it will be lambda minus 2, 0, 0, negative 5, lambda minus 2, negative 1, 7, 0, lambda plus 3. So if we do cofactor expansion along the first row, so we get lambda minus 2. Now we hide first row and first column, so we get lambda minus 2, negative 1, 0, lambda plus 3. So this one is triangular matrix. So we get lambda minus 2 multiply lambda minus 2, lambda plus 3. So here the determinant is, since it's triangular, we multiply the entries of the main diagonal. So finally we get lambda minus 2 squared, lambda plus 3. So P lambda equals 0. We get eigenvalues. Lambda minus 2 squared, lambda plus 3 equals 0. So we get lambda 1 equal 2, lambda 2 equals 3. Multiplicity equal what? So here, minus 3, very good. I did the same mistake of Nora. So you see Nora? Same mistake. So, no, why? For what? Sorry. No problem. It's better to do mistakes, by the way, but not in an exam. So here, what's the multiplicity of lambda equal to, guys? Here, what's the power? Lambda minus 2 to the power of 2, so multiplicity is 2 because of this one. And here, multiplicity is 1 because of here. Anyway, no need. Is it clear, guys? Very good. Now, the matrix A is 3 by 3, but we have two eigenvalues. Please, if you want, take screenshot. Is it diagonalizable? What should we do to know if it's diagonalizable? You mean you kept it like this, Abdullah? Very good, Nora. Yes, but the most important to know multiplicity. How many times is repeated? 2 times. You have to know. Okay. So very good, Nora. We know to see if A is diagonalizable. Since we have only 2 eigenvalues, so we don't know if it's diagonalizable or not. So we have to find all eigenvectors. If we have 3 linearly independent eigenvectors, means it's diagonalizable, right? If we have a basis, if the eigenvectors form a basis, means diagonalizable. Yeah, very good, Nora. Stop. Let me do it again. So what was P lambda, guys? The determinant? Or you just, yeah, P lambda. What was here? Lambda minus 2, 0, 0. And then here, what was the numbers, guys? Minus 5. Here, lambda minus 2 and minus 1. Okay. And negative 7, I remember. 7. 0, lambda plus 3. So, very good. Now, part B. Is A diagonalizable? So since we have only 2 eigenvalues, we don't know if it's diagonalizable or not. To check, we have to move to eigenvectors. We have to check the eigenvectors. So let's check eigenvectors for lambda 1 equal what? 2. We solve lambda 1 I3 minus A V equals 0. So here it's A, B, and C. Very good, Nora. So we solve if lambda equal 2, you get 0, 0, 0, 0, negative 5, 0, negative 1, 0, 7, 0, 5. Correct? Okay. Now, R2 divided by negative 1. This one, R1 and R3. And this one also interchanges with R1. So what do we get? Divide by negative 5 to make 1. So we get 1, 0, 1 over 5, 0, 7,050,0,0,0. R2 plus minus 7 R1 101 over 5 0 0 0 minus 7 5 minus 7 over 5 we get how much? What is that? 5 minus 7 over 5, so 18. So here we multiply R2 by 5 over 18, right? Means we divide by this number. So we get 101 over 5, 0, 0, 0, 1, 0, and all zeros. A, B, C. I have leading 1, leading 1. Here 0 equals 0 because it's homogeneous. Very good. B is free. And C equal what? 0. A equal minus half, minus 1 over 5 C. But C is 0, so A also 0. So V, which is ABC, it's equal to 0, B, 0. We take B different than 0 to have an eigenvector. Very good. So V1, 0, 1, 0 is an eigenvector for lambda 1 equal to. Don't forget, multiplicity of lambda 1 is 2. We must have 2 eigenvectors. For sure, it's not diagonalizable. Because we will have again 1, we will have 2 eigenvectors. It is possible to have bases with 2 eigenvectors, right? Because, look here, we have 2 eigenvalues. Lambda 1 equal 2, lambda 2 equal minus 3. This one, how many eigenvectors we have? V1. And here we will have only V2, right? 2. We have 2 vectors. Is it possible to have bases with 2 vectors for R3? Here it's 3 by 3. So for sure it's not diagonalizable. To be diagonalizable, we must get number of eigenvectors equal to multiplicity. Here we get only 1. We need 2 because multiplicity of 2 was 2. Remember? Lambda minus 2 squared. It was 2 here. For that we use multiplicity. Anyway, let's check for lambda. Take screenshot, guys. Guys, this is the last question for this course. Okay. Lambda 2 equal minus 3. So for lambda 2 equal minus 3, lambda 2. So minus 3 minus 2 minus 5, 0, 0, minus 5. Minus 3 minus 2 is minus 5, minus 1, and 7, 0, 0. R1 divided by minus 5, 1, 0, 0, 0, negative 5, negative 5, negative 1, 0. R2 plus 5, right, Noura? And R3 minus 7, R1. So we will get 1, 0, 0, 0, 0, negative 5, negative 1, 0, and all zeros. And here R2 divided by negative 5 to have a leading 1. 0 and all zeros. Leading one here. Plus, okay, very good. Leading one. C is free. Correct? Very good. Not 0, I think. Look here. B plus 1 over 5C equals 0. So B equal minus 1 over 5C, right? And A is 0. So V, which is ABC, it's equal to 0 minus 1 over 5C and C. We take very good C equal 1. But look, let's take something without fraction. So what do we take? I mean, let's choose C such that we don't have fraction. 5, very good. Different than 0. So V2 is 0, negative 1, and 5. So you see, we don't have fraction. Minus 5 also. Yes, you can take minus 5, so you get 0, 1, minus 5. I go, so again, it's true. Eigenvector associated with lambda 2 equal to minus 3. So is it diagonalizable? Conclusion. V1, V2 cannot be a basis for R3. So A is not diagonalizable. So if you want, you can take a screenshot how to find V2 and okay, Abdullah? Okay, and that A is not diagonalizable because to have A diagonalizable, we need the eigenvectors to form a basis. Yes, but here, 2, impossible to have basis because a basis for R3, we need many. How many vectors do we need for R3? Very good. We need 3. So here we have only 2. Very good, guys. Any question, guys? Do you understand? So you see here, since number of vectors is less than multiplicity, for sure it's not diagonalizable. If it's equal, maybe yes, maybe no. Okay. Now let's erase. I give you one small matrix and I want you to solve it. Okay, guys? It's from the textbook, from section 7.2, exercise 10D. So find, if possible, a non-singular matrix P such that A equal to P D P minus 1, where D is a diagonal matrix and A is given by 0, negative 1, 2, 3. So we want to see if A is diagonalizable. If A is diagonalizable, we know that we can write A is equal to P D P minus 1, and P will be V1, V2, and D will be lambda 1, lambda 2, right? Okay, do it, please. If we have two distinct eigenvalues, means diagonalizable. Abdullah, this one is diagonalizable. Please do it, all of you. I will give you 10 minutes. Yes, correct, Abdullah. Yes, correct, Hamad. Very good. Yes, and continue how to find P and D. And Nora, you get the same? Okay, very good. Yes, correct. Okay, Nora. No problem. You can fix it. Lebanon. Guys, let's see. Maybe Nora, you get -1 and -2. Let's do it. Let's check. Uh, no, it must be 1 and 2. Let's check. P lambda, lambda -0, lambda 1, -2, lambda -3. So multiply. Lambda multiply lambda -3 minus -2, so +2. So we get lambda squared -3 lambda +2, right? You get this one, Nora? Maybe here you did mistake. And now P lambda equals 0, lambda squared -3 lambda +2 equals 0. So lambda 1 equal 1, lambda 2 equal 2. We have, very good, we have two distinct eigenvalues. For A, which is 2 by 2. So A is diagonalizable. Correct? Okay. Now how to find D? D, it's very easy. Lambda 1, lambda 2. 1, 0, 0, 2. You see it's diagonal? Diagonal matrix. Very good. How to find P? Also very easy. It's equal to V1, V2. V1 is eigenvector for lambda 1, V2 eigenvector for lambda 2. Two zero zero one. Okay, let's check. You get 2001, right? Okay, let's check if it's correct. So let's find lambda 1. Easy. We need to find eigenvalue, means you substitute instead of lambda, put 1. No problem. If you switch, then you have to switch here. You put 2 and 1. Okay, no problem. So if lambda 1 equal 1, put instead of lambda 1, 1, 1 minus 2, minus 2, 0, 0. R2 plus 2 R1, so we get 1, 1, 0, 0, 0, 0. A, B, B is free. A equal minus B, so V, which is AB, it's equal to minus BB. So we take V1 equal what? Minus 1, 1. So how come, guys? We get minus 1 and 1. It's different than what you said. If lambda 2 equal 2, so 2, 1, 0, negative 2, negative 2, negative 2, and 2 minus 1, 0. R1 divided by 2, so we get 1 half and 0, negative 2, negative 1, 0. R2 plus 2 R1, so we get 1 half 0, 0, 0, 0. B is free. A equal minus half B. So V, which is AB. I didn't change the sign. Which sign? No, here. You have to substitute here. But instead of lambda, put 2. Not here. Not this one. Here, forget this one. Yes. So here, AB, which is A is minus half B and B. Let's take B equal to. So V2 will be minus 1 and 2. So let's write here P. B, which is V1, V2 will be, V1 is minus 1, 1, V2 is minus 1 and 2. And guys, what's the determinant of this matrix? Let's check if it's not singular. For sure non-singular. No problem, no problem. If you put lambda 1 equal 2 or lambda 1, no problem. It is the same, but in this case, you have to keep the order. I will show you. Look, if you say, let's erase here. Here is nothing. Even if you didn't take screenshot, no need. Look, Abdullah. If you want to say that D, lambda 1, 0, 0, lambda 2, it's equal to 2, 0, 0, 1, okay? Then P, it will be V1, V2, V1 is for lambda 1. Where is V1? Which is for 2. For 2 is this one. Then in this case, you have to switch it also. So you see, look, I switch, not the same. Okay? You have to keep the same order. Yeah, very good. Any question, guys? Very good. Guys, please, I advise you to revise, start revising from span, linearly independent bases for subspace, linear applications, linear transformations, and the standard metrics, standard bases, and chapter 7 means 3, 4, 5, 7, and so we can discuss your questions on Thursday. Okay, guys? So Thursday, I will listen your questions. Is it clear? Very good. So now we are done with chapter 7.2. So if you don't have any question, please prepare everything for Thursday. Now, guys, if you don't have questions, you can leave. Thank you very much. Do we need P minus 1? Yes, prepare data for sure. Nora, they are not asking. They are asking just to find P and D, non-singular. Means we want to see that A is diagonalizable, so we can write A as P, D, P minus 1, but since they didn't ask for P minus 1, no need. Thank you, guys. Enjoy your day, and I see you on Thursday.